بسم الله الرحمن الرحيم والصلاة والسلام على أشرف المرسلين. أما بعد. Hello everyone. I'm aymen benmakhlouf, PhD student in Materials Chemistry at Biska University. I have pleasure and honor to be a part in the first international conference in chemical matters and environment preservation to represent my research with the title The Effect of Synthetic Temperature on the Density of Oxyfluoride Ceramics on the PZT type prepared by the conventional solid-state reaction. In our work plan, we will present firstly introduction, experimental parts, result and discussion, and finally conclusion. The objective of this study is to find the optimal temperature when the density of the PZT ceramic is maximal, and to search for PZT type oxyfluoride ceramics close to the morphotropic phase boundary with stable and reproducible characteristics. And we will add XRD structure study, morphological study SAM, and study of porosity and optimal density. The discovery of polarization switchable polycrystalline ceramics in the 1940s launched a worldwide search for new piezoelectric materials and their applications. The global market for piezoelectric devices reached 20 billion in 2012 and continues to grow steadily. PZT type ferroelectric ceramics with this general formulation are widely used in many technological fields due to their dielectric and electromechanical properties. This is due to their unique properties, combining high electromechanical coupling factors, operating temperatures, relatively low production cost. It's possible to modulate these properties and obtain specific characteristics for specific applications, precise by making cationic and anionic or anionic substitutions in the crystal lattice of the PZT base materials of perovskite structure. Experimental parts. A series of composition of PZT will be prepared by many oxides, like lead oxide, zirconium oxide, titanium oxide, aluminum, and antimony oxide. We will grind them for 6 hours in acetone medium, and we will put it for calcination with 1000 degrees Celsius for 6 hours. We measure the mass, and after grinding, we put them in a mud of 10 mm after we put it in the press. Finally, we have seen that all the analysis when we have done within the University of Biskra give us almost acceptable results. We were able to conclude the importance of having a compositional of biphasic structures, T plus R. The diffractogram shows that all the samples we analyzed are clearly pure, and we got nothing like secondary phase. And the most important is the find in our diffractogram that we are in morphotropic phase boundary, and to be more precise, we can notice that there are peaks focused in 2 theta between 43 and 46. For more explications, this is our diffractogram. Actually, there is 3 peaks like we see here. The first and the third peaks is tetragonal phase, and the second is for the rhombohedral phase. So we can calculate the percentage of existence of these phases. We can see that the rhombohedral phase is 52% and the tetragonal is the 47%. The texture, porosity, and grain size of sintered materials was observed by SAM. The chemical microanalysis was made by ODX. As we have seen, the effect of sintering temperature and density that, except the curve A2, we have almost obtained the curves that we are shown that the optimal temperature in which we have obtained the maximal density is 1230 degrees Celsius. Conclusion. From the diffractogram of XRD analysis, it is concluded that all samples have perovskite structures without impurity phases, which suggests that the barium ion have fully diffused into the PZT lattice to form a solid solution. In relation to the density, we have forced that it is necessary to do several sintering at different temperatures for each composition to reach the optimal density. We have almost obtained the clouds that they are shown that the optimal temperature in which have obtained the maximal density is 1230 degrees Celsius. Thank you for your attention.